So here the two choices are given and we need to answer one of them. We'll be discussing both here. First question is list three differentiating features between the process of galvanization and alloying, and the second is compare in tabular form as to how these three metals mentioned here react along with cold and hot water. So let's go to the explanation. Here first let's talk about differences between galvanization and alloying. Galvanization is a process of protecting steel and iron from rusting by coating them with a thin layer of zinc. So a thin layer of zinc is put on the steel and iron, as a result of which it protects it from rusting. Alloying is also a very good method of improving the properties of metal. We can get the desired properties by this method. For example, iron is mixed along with nickel and chromium. We get stainless steel, which is hard and does not rust. So here we get a substance with new properties, which leads us to our second difference. Galvanization doesn't modify the property of metal. It just adds an additional layer of zinc on top of the steel or iron, basically on the metal, whereas alloying modifies the property of the metal. And galvanization, the coating of zinc is removed, then rusting takes place. When the layer will get removed, rusting will start taking place again. Alloy will not rust. Now comes the second question, where we had to compare the reactivity of metals along with cold and hot water. So let's write the first difference or compare using the reactions. So 2Na plus 2H2O, Na in solid form and H2O in liquid form will give us 2NaOH, which will be in aqueous form, and H2 gaseous form, plus heat energy will be released. In case of calcium, the reaction would be calcium plus 2H2O gives calcium hydroxide plus hydrogen. Then it would be magnesium plus 2 times H2O, which would give us magnesium hydroxide in aqueous form, plus hydrogen gas would be released. The reaction of sodium with cold water is very violent, because as we can see that heat energy is also released in this case. It is highly exothermic, again heat energy released. It also reacts with hot water in the same way. Then calcium, the reaction of calcium with cold water is less violent. Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of metal. It also reacts with hot water as well. Magnesium does not react with cold water. There is no reaction, and it reacts with hot water, which leads to formation of magnesium hydride. It also starts floating as the bubbles of H2 gas stick to its surface. H2 gas shown here, it's released.